think we're ready to roll. Okay, so section 1.3 is about midpoints and distances. We've got formulas for each, and we're going to do some explorations today to develop what those are. I'm going to have you guys kind of discover what they are. But we need to do a little bit of vocabulary here to get started, just so you guys are familiar with a couple of terms. So first things first, we need to define what a midpoint is. And very simply, a midpoint is a point that divides a segment into two congruent segments. Okay, so off to the side here, draw a picture of that. All right, so let's say I got segment AB. All right, so if I have located the midpoint, we'll call it M. Then we've got these two smaller segments now, and they are congruent to one another. So the way that we mark that is we just do a little tick mark on each one of them, kind of like that. Okay, and that just shows on the picture that AM is congruent to MB. Okay, so their lengths are the same, right? We talked about that yesterday. Okay, so when we're talking midpoints, we also need to talk about bisectors. Okay, or more specifically, segment bisectors, because we're going to talk angle bisectors in a little while. So a segment bisector, it could be a ray, a line, a segment, etc. That intersects a segment at its midpoint. So one of the kind of questions you're going to be asked in your homework is they're going to give you a picture and ask you to identify the bisector. Okay, so let's take a look at that. So if I've got a segment here, I'll put a ray on it here. So let's say C, D, E, F, and those are congruent. Okay, so first of all, in that picture then, identify for me the midpoint. Where's the midpoint? Yeah, D. Okay, so if D is the midpoint, where's the bisector? What is the bisector? Yeah. F. Not just the point F. It's the entire object. Yeah, it's DF, right? It's the ray DF, that whole thing. Remember I said it could be a ray, a line, a segment. Okay, it's not just a point, but it's one of those other objects that's kind of cutting through the segment, hitting at its midpoint. So for this one, yeah, the bisector is the ray DF. Okay, so we're going to stop here for a moment. Okay, so midpoint formula. So we said it's like doing an average. Okay, so if you have 2 points, and I'm going to keep them generic because it could be any 2 points. So we'll just call them x1, y1, and x2, y2 are our 2 points. Okay, so the midpoint is another ordered pair. Okay, so we got the parentheses. Leave yourself a little bit of room here, though. And we want to average the x's and average the y's. That's going to put us in the middle. So the x-coordinate would be x1 plus x2 divided by 2. And the new y-coordinate would be y1 plus y2 divided by 2. And that's it. Okay, so we're going to practice this a little bit. So I'll give you a couple of ordered pairs, see if we can just plug the numbers into the formula real quick and get what the midpoint would be. Otherwise, you could, I suppose, graph the thing and try the little counting the boxes deal. But the formula is, I think, a little bit easier in this case. So you don't have to mess with the graph. Okay, so find the midpoint of 3, -1, and -2, 5. Okay, so it's just doing a substitution. Take the 4 numbers, boom, 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 plug them in, crunch the numbers on them, and then see what we have. Okay, so this is like your x1, y1, your x2, your y2, okay, in these 2 points. So if I add my x's and divide by 2, I got 3 plus -2 divided by 2. And then I'm going to average my y's. So -1 plus 5 divide that by 2. And then I just got to figure out what each one of those 2 fractions are. So let's work on the first one. What is 3 plus -2? Oh, you got a question? No, oh, you're going to answer my thing here. 1, yep. Yep, and what's 1 divided by 2? 0.5, yep. Or I'll just leave it as a fraction, 1/2, but you can use decimals if you want. Okay, somebody else, the next one. What's -1 plus 5? Divide that by 2. 2, good. And our midpoint of that segment created by those 2 points is 1/2, 2. Okay. Now, they might get a little tricky with you here. And maybe instead of giving you 2 endpoints, they give you an endpoint of the segment, and they give you the midpoint, and they want you to find the other endpoint. Okay? So, like, I'll draw a picture with this one to clarify a little bit. So let's say this point is at -4, -3. This point is at 0, 5. And then this one is what we want to find. We don't know. Okay, now there's several different ways to do this. Now think about what we talked about and in that exploration about how we can kind of count our way to the middle and how the midpoint is halfway along the journey. What do you think we could do to find the coordinates of that last point? Yeah?
Wouldn't you have to times it by 2 and subtract it?
Times it by 2 and then subtract it. Yes, you could do that. You could multiply. That would be kind of using the formula, but like undoing it. So you would multiply the coordinate of the midpoint by 2 and then subtract the coordinate of the endpoint. Now, if that works, that's great. I think for a lot of people, though, that might get a little confusing about what goes where when you do that and everything. So, but I don't want to poo-poo it because you can use it. But what might be an easier way to do it, though? I sure did. Yep. What? Add them together? Sort of. You're on the right track. You're not exactly going to add these coordinates together.
Well, you're going to have to add like -4 plus 0 or -3 plus 5.
Well, how about this real quick?
And then,
Can you tell me?
Have a negative.
Well, hold on a second. Can you tell me what the x coordinate of this point right here should be?
Wouldn't it be
4. Now, how do we get 4?
Well, because I plussed it and I knew it can't be a negative.
So, oh, okay. But sometimes they are negative, so we can't always do that. So, anybody else, though, that want to clarify that?
That depends on which way the line's going. Because the line's going that way, it's going to be negative.
It's true, but I want just one thing that's always going to work. We're close, though. Yeah.
Count the squares in between there and then add it to the top part.
Okay. And you know what? He's right. He said we can count squares and see how far that is and then do it again. We don't even need the squares, though. We've got numbers that we can use to do that. Okay? So, shh, guys. So you can follow me here. From -4 to 0, how far did I go? Up. 4. So I need to go 4 more, right? So this should be a 4. -3 to 5, how far up did I go? So I got to go 8 more, right? What's the other coordinate? 13, thank you. 5 plus another 8 would be 13. All right, so shh. Here's how I showed one of my classes in the past, and it seemed to work pretty well. I lined them up. I put the midpoint in the middle, and then we talked about how far are you going from each one. So from -4 to 0, I went 4. From -3 to 5, I went 8. Then I got to do it again. Another 4. Another 8. 0 plus 4. 4. 5 plus 8. 13. Okay, so your other endpoint is 413. Okay, you're just counting up. Go the same distance you went from the one endpoint to the midpoint, do it again, and that'll get you to the other endpoint, okay? All right, I'm going to stop this. Okay, shh. So, the distance formula. This is another way that you can do this distance calculation stuff. There's actually 2 methods. And I'm going to do an example with you guys, and I'll do both methods so you can choose which way you want to do it. It doesn't matter to me. I happen to like doing it the Pythagorean theorem way, but you can use this equation as well. All right, and this equation comes directly from the Pythagorean theorem. I could do a proof for you and show you and all that and everything, but we don't really have time for that. So I'm just going to write down the formula for you, but then I'll show you, like I said, both ways of doing it. So the distance formula looks like this, and you've probably seen this before. It's a big giant square root, and it's x2 minus x1 squared plus y2 minus y1 squared. The advantage of the distance formula is you don't have to draw anything. All you need to know is the numbers and you plug them in. The downside of the distance formula is I'm not going to give this to you. I'm going to expect you to know it if you're going to use it. So you'd have to memorize it. Now some people memorization and they're like, they seize up and they don't want to do it. Some of you might look at that and say, oh, I can kind of see the pattern in there. I could memorize that. That's not a big deal. So it's just up to you. Okay? So let's try an example. Oh, do you still need more time? I'm sorry. It's there are minus signs inside the square or inside the parentheses, and it's a plus sign in the middle. Okay, so it's x minus x squared plus y minus y squared. So yeah, this is a plus sign. It pretty much is the same thing. It's just written as a formula. Yeah, this is a subscript. This is a 2. This is a 1. This is a 2. This is a 1. And then they're each outside the parentheses are squared. All right. Are we okay to move on? Okay. All right, so we're going to find the length of a segment AB, and I'm going to give you coordinates for A and coordinates for B. So A, come on, pencil. So A is going to be 2, -5. And B, 7, 2. All right, so the first method, we'll do the formula. All right, I know you guys probably don't want to do this if you use the formula, but the first thing that I would do with this, just so you don't make any mistakes, is to actually write the formula out without any numbers in it. I always do that whenever I use a formula for anything, because that way, if something does happen where I've made a mistake, I can go back and I can see where I made my mistake. So it's x2 minus x1 squared plus y2 minus y1 squared. So I've got that down first. I just double check that that's right, and it is. Okay, now I can start putting numbers in. So that's going to be the square root of x2 minus x1. Well, find the two x's. x2 usually refers to the second x, so that would be this one. And x1 is the first x, that would be this one. So 7 minus 2 is what we're going to have right here then. So parentheses, 7 minus 2 squared. And then we got to subtract our y. So y2 minus y1. y2, 2. y1, -5. So 2 minus -5. And then that's going to be squared eventually. All right, so doing order of operations, I got to do my subtractions first. What's 7 minus 2? 5. Okay, thank you. So 5 squared. And then what's 2 minus -5? That would be 7, right? 2 minus a negative is 2 plus, so it's 2 plus 5 is 7. Okay, and then we got to do the squares now. What's 5 squared? What's 7 squared?
25 and 49.
25 plus 49, yep. And 25 plus 49? 74, good, yep. Okay, so the distance is the square root of 74. Now, unlike the other ones that we did, this isn't coming out to a nice, neat number, right? But you can leave it that way, exactly. Or if you like decimals, there are people that enjoy decimals more than leaving it as a square root. I'm totally fine with that, too. It ends up being about 8.6, I believe. If I remember correctly from third hour. Yeah, 8.6. Okay, so that's using the formula. Okay? It's very algebra heavy. Okay, you got order of operations and all that too, and you got to remember the formula, and it takes a little bit. Method 2, this is the one I like to use because I'm kind of a visual person. I like to see it. So this is using a graph and the Pythagorean theorem. If you have a hard time drawing a nice, pretty graph, this might not be the one for you. So, because the first thing you need to do to be able to apply the Pythagorean theorem is to plot the points. So, A is at 2, -5. So, 2, 1, 2, 3, 4, 5, -5. And then 7, 2, so 1, 2, 3, 4, 5, 6, 7. And then up to 2, 1, 2. So 7, 2. Okay, so here's our segment we want to find the length of. And this was, let's see, this is A, this is B. So we're going to do like we did before. We're going to make a triangle out of it. And then we just got to figure out how far these two segments are on the bottom and on the side. So we can count it again, as long as we've been consistent with the little tick marks, okay, and careful with that. So over, how far did we go? 5. Okay, so it's 5 over. And how far up and down? 7. Okay. So if I'm going to do the Pythagorean theorem, I've got A is 5, B is 7. So 5 squared plus 7 squared equals C squared. Okay. The actual calculation part of this one's a little bit easier. Okay, because we don't have to do all that subtraction and big square roots and all that. So 25 plus 49 equals C squared. And again, what is 25 plus 49? 74. If 74 equals C squared, I got to square root both sides of that. So C is equal to square root of 74, which is the same answer we got up there, right? And if you like your decimals, 8.6. So, like I told third hour, pick your poison. Which one do you like better? Or which one do you hate the least? I don't know, whatever. So, but that's how you got to do it. One of the two. All right? So.